Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif bin Syahir. Today I can present about the IR 4.0. IR 4.0 is a combination in traditional and the industry platform. The increase the automation and monitoring control the system. So our group can choose the SCADA system to our topic. Today I can present about the SCADA system. SCADA system stands for the supervision of control and the data acquisition. It is a type of the software application program for the process control. SCADA system is a centrally control system which consists of controller network interface, input-output communication equipment, and the software. SCADA systems are used to monitor and control the equipment in the industry process, which include manufacturing, production, development, and exploration. The instrumentation process include oil and gas distribution, electric power, water distribution. Public unity include the bus traffic system, airport. The SCADA system take the reading of the meter and check the status of a sensor in regular interval, so there is a requires minimal intervention of human.
Hello everyone, I'm Nilesh. I'm here to talk about the type of SCADA.
There are different types of SCADA system that can be considered as SCADA architecture of 4 different generations. First generation SCADA system is called as monolithic or early SCADA system. In earlier days, many computers are used for computing the SCADA system. Monolithic SCADA systems were developed wherein the common network services were not available. Hence, these are independent systems without having any connectivity to other systems. The second generation is called as distributed SCADA system. In the second generation, the sharing of control function is distributed across the multiple systems connected to each other using local area network. Hence, these were termed as distributed SCADA system. These individual sessions were used to share real-time information and command processing for performing control tasks to trip the alarm levels of possible problems. For the third generation, it is called as networked SCADA system. The current SCADA systems are generally networked and communicate using wide area network over data lines or phones. These systems use Internet of Fiber Optics connection for transmitting data between the nodes frequently. This third generation SCADA system use programmable logic controllers, or called as PLC, for monitoring and adjusting the routine flagging operators only in case of major decision requirements. Finally, for the fourth generation, which is called as Internet of Things or IoT. In fourth generation, the infrastructure cost of SCADA system is reduced by adopting the Internet of Things technology with commercially available cloud computing. The maintenance and integration is also very easy for the fourth generation compared to the earlier SCADA system. These SCADA systems are able to report state in real time by using horizontal scale from the cloud computing facility. Thus, more complex control algorithms can be implemented which are practically sufficient to implement on traditional PLCs.
Hello, my name is Abdul Hadi and I will present to you how SCADA works.
Before we understand how SCADA works, we need to know what a SCADA system do. In a simple term, a SCADA system is a collection of software and hardware components that allow manufacturers to perform a series of specific functions. These functions include controlling manufacturing process locally or from an off-site location, interacting with field device and control stations like sensor and motor via human-machine interface display, monitoring and gathering process data in a real-time, recording system even in a log file. And now we will tell you the working procedure of SCADA system. The SCADA system performs the following function: data acquisition, data communication, information, data presentation, monitoring, and control. In data acquisition, a real-time system consists of thousands of components and sensors. It is very important to know the status of particular component and sensor. Data communication. The SCADA system uses a wired network to communicate between user and device. The real-time application uses a lot of sensors and components, which should be controlled remotely. The SCADA system uses internet communication. All information is transmitted through internet using specific protocol. Sensor and relay are not able to communicate with the sensor protocol, so RTU used to communicate sensor and network interface. Information and data presentation. The normal circuit network have some indicator which can be visible to control, but in real-time SCADA system there are thousands of sensors and alarm which are impossible to be handled simultaneously. The SCADA system uses human-machine interface to provide all the information gathered from the various sensors. The human-machine interface. The SCADA system uses human-machine interface. The information is displayed and monitored to be processed by human. Human-machine interface provide the access of multiple control unit, which can be PLC and RTU. The HMI provide the graphical presentation of system monitoring and control. The SCADA system uses different switches to operate each device and display the status of the control area. Any part of the process can be turned on and off from the control station using the switch. SCADA system is implemented to work automatically without human intervention, but critical situation is handled by manpower.
Hello, I'm Karthik. Today I'm going to present about the advantages of SCADA system.
Okay, following are the benefits or advantages of SCADA. The system provides facility to store large amount of data. That means the system is having a huge storage to store a lot of data. Okay, other than that, the data can be displayed in various formats as per user requirements. It will be very helpful for the user to display the data. Okay, other than that, it provides interface to connect thousands of sensors across wide region for various monitoring and controlling operations. It is also possible to obtain real data simulation with the help of the operators. Okay, other than that, many types of data can be gathered from RTUs, which is remote terminal units connected with the master unit. Okay, the following advantage is, with the advanced protocols and application software, the data can be monitored from anywhere and not just from the local site. Okay, the redundancy of units are incorporated in the SCADA system in order to have backup in the event of faults or failures. This makes the system more robust. It is fast in obtaining response. It is also scalable and flexible in adding additional resources. Okay, it is also used in wide industries and departments including telecommunications, energy, transportation, oil and gas, water, military, meteorological, and etc. This SCADA is very easy and cheap to be used.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Salim bin Ibrahim. I will continue this video presentation with disadvantage of SCADA system. SCADA systems are much less reliable than PLC and DCS. This is because of the following reason. First, SCADA systems are updated quite frequently to add or change tab, unit of measure, script, alarm, threshold, and synoptic. This means that SCADA applications have to be restarted often. They usually run on Windows operating system, so they are also frequently rebooted to apply security patches of other installation tasks. SCADA systems are built on several modules that execute different tasks. Sometimes those might be overloaded and they may drop the communication tasks that are in charge of feeding the IoT data stream. It has restricted software and hardware. Different operating skills are required, such as system analyst and programmer. With thousands of sensors, there is still a lot of wire to deal with HPOF. The operator can see only as far as the PLC. PLC SCADA system has complexity of system hardware and depends module lead to low reliability.
Hi, I'm Azila. As we know, SCADA systems are used for control monitoring and control. So, this is my discussion. Not all SCADA systems are the same, but studying them from a security point of view, they can be broken down into the following components that are present in every system in one form or another. First, data acquisition, data conversion, data communication, and lastly, data presentation and control. Each component has a well-defined function or purpose. Furthermore, each component has a specific relationship with the components that it communicates with. SCADA system can be broken down into following major components, which form a chain. Each component communicates with the component before and after itself.
Hello guys, my name is Muhammad Adi Akmal bin Azhar. So for the conclusion, in the end, both SCADA and IoT involve sensor and data acquisition. Although they do differ in many aspects, they both share the one common goal, the optimize of use and eventually better control over some device or a process. The whole idea is smart grid leader to SCADA and IoT integration. As SCADA is not a full control system, rather the computer system that gather and analyze real-time data. It is useful in monitoring and controlling a plant or industrial equipment. It will then carry out any necessary analysis and control and display the information in a logical or organized fashion for human to the interrupt and use accordingly. Both platforms offer an abundance of advantage as well as some vulnerability. It is predicted that by 2020, 50 billion devices or things will be connected to the internet. Therefore, the dynamics of an internet-based control system are becoming a living reality. Industry 4.0 is an era which imagine trend automation and data exchange. in manufacturing technologies are allowing for a shift from traditionally implement SCADA to an IoT implement one. With SCADA, cyber physical system, the Internet of Things, cloud computing, and cognitive computing. Industry 4.0 is an era that will change the dynamic of the entire automation industry.
Peace.